Hello everyone, today we are gonna solve most frequent subtree sum problem. So in this problem, we have a binary tree. Let's say our binary tree is something like 2. And what we have to do, we have to find the most frequent subtree sum. So first of all, what is subtree sum? So here you can see that this is my subtree, the single node is my subtree, so its sum is 2. This minus 5, this single node is also subtree, so its sum is minus 5. This is a tree, so what is sum of it? So 2 plus 5 plus minus 5, so it will becomes 2. So I can say this 2 is the most frequent sum. How many subtree we have which have sums 2? It is 2. How many subtree we have which have sum minus 5? So it is 1. So here we can say that 2 is most frequent subtree sum. So we will return 2 here. Now let's say another example. If I have 2 and this, in this case, what will be my most frequent sum? So you can see this 2. I have this 2 one time. So sum of this subtree will be 2. Sum of this subtree will be 1. So 1 is also occur once time. And this 5, and the sum of this whole subtree will be 5 plus 2, 7 plus 8. That is 8. That is one time. So in this case, if all of them, if not all of them, if my most frequent is 1, here most frequent is 1. So if I have many subtree sum which have the same frequency, in that case I will return whole every sum. So in this case I will return 218. So now how do we solve that? Let's understand the intuition first. So what we will do, before finding the most frequent element, I should know how to find the subtree sum. So how I will find? So if I have this tree, so how do I find the subtree sum? So first of all, there are two approaches to solve our the trees problem, by the trees problem. So we can do top down or bottom up in recursion. So here, what should I do? If I am here, so how can I find what will be the subtree sum? What will be its tree sum? So I can simply say, whatever is returning from here. Let's say from here I get my left sum, and from here I will get my right sum. Sure. So whatever comes from here and here, I will add my root value into it. So I will have my left sum, I will have my right sum, and I will have my root value, and this will make my current subtree, this subtree sum. So this is how I will find the subtree sum of my tree. So for every node, let's say if I have a single node, so this null will return 0, so its sum will be 0 plus root value 2. So if I have a tree something like 2 and this is 1, so what will be its sum? Its sum will be subtree sum. So first of all it will be 0, so this is 1, this subtree sum is 1, and now from here it will get 0, from here it is getting 1, so its sum will be 0 plus 1 plus 2, that is 3. So now I got this 3 as my final subtree sum. So now let's understand this. Now what I will do, I have to find the frequency. So for frequency, what we do generally when we need see frequency question, we use map, where we store the count the frequency. So what we will do, when the sum is written, when we find this sum, before returning from here I am returning this 1. Before returning this 1, what I will do, I will add this sum into my map. So now I will add this 1 and make that it is occur one time. I will make this 3 and make it like it occur one time. Okay. So now after doing this, once my BFS, DFS, any approach I can use, once my DFS is done, then what I will do, I will iterate through this. Should I iterate through this? No. What I have to do, this unordered map have this in random order. First of all, for finding this most frequent, I will sort this. So if I write down my steps, so it would be look like. So the first thing we have to do is the count the subtree sum and have to store that sum in map and store it in map. We will have another map. Okay, then what we have to do, we have to this sort this sum, sort the subtree sum according to the frequency, according to frequency. So once we do this, once we done these two steps, the last step will be if let's say our most frequent, the most frequency subtree sum is k time. Our most frequent is k time. So all the subtree sum which have the frequency k, we will add that all that frequency subtree sum into our vector, and then finally return this vector. So this is simple 3-step procedure. So now let's check out the code and analyze the time and space complexity. So first of all, what we are doing is, first of all, we are using this another map for count the subtree sum and store it into our map. So how do I doing this? So using this solve function, do a DFS call. This is the DFS, simple DFS, where first of all it find its left sum and then it find its right sum. Once it find its left and right sum, then it will find its current root sum, and once it find that root sum, it will store it into our map. So if I do a dry run, so you can see here. So first of all, I am sending this 5 to this solve function. So this 5 is gone, and this 5 will call its left, so it will be gone this 2, and this will call its root left, then this will return 0, and its right will also return 0. So its left and right is returning 0. So what I will do, okay, so left and right is returning 0. What will be the root value? Current root value is 2. So I will return from here, I will return 2. Before returning 2, I am marking this 2 with 1. Its frequency is 1 right now. Now this 2 is done. Once 2 is done, it will call my right. This is 1, and it will also get 0 from left and 0 from right, and its current value is 1. So it will make my 1 sum as 1, and it will return 1 here. So from left it will getting 2, from right it will getting 1. So its sum will become 2 plus 1 plus 5, that is 8, and 8 is 1. So now in this case, right now where I am at this step. Now what will happen? After that, I can use either thing. I can use a vector and put my map values into the vector and then sort them, or I can use simple priority queue. So what does this priority queue will do? This priority queue will count this, and now what I will have this in, I will count this frequency because I have to sort it frequency wise. So I have sorted this, so I will have here something like this: 1, 2, 1, 1, and 1, 8. So after this will be in my priority queue. So after that, what I will do, I will see that I have my vector answer, and I will see what is my top frequency. Its frequency is 1. So if its frequency is 1, then I will pop all the element whose frequency is 1. I will pop all the element and store it into this. So its frequency is 1. I will add 2 into my answer, 1 also into my answer, and 8 also in my answer. Once I have done this, now let's say if there are many more, right now it is empty. If it is empty or its frequency is less than my current frequency, in that case I will not pop other elements. So once this condition falls, I will return my answer. So now let's understand what will the time and space complexity. So for using this, our time complexity will be of n, and for priority queue, take log n for push and pop operation. So here in max, what we can do, there can be n items, so it can be n log n, and for popping also it can be n log n. So overall time complexity will be n log n, and the overall space complexity for this another map and this priority queue will be of n. So this is the time and space complexity. I hope you understand the intuition and the source code. If it helps you, do not forget to hit the like and subscribe button. Thanks for watching.